Sorry kau kau.
Dah. Hello, my name is Nabila. So today I will explain the design task D for integrated project. So firstly, we're using the atomic equation ln P1 set equals to A minus B divided by temperature plus C. The temperature we are using in unit of Kelvin, and then A, B and C can be obtained from table B2 appendix. So P bubble is equals to summation of x1 times with P1 set. So if we have two components, so this is the meaning of summation here. And then the next one is y1 equals to x1 times P1 set over total pressure. So this is the Rock's law that we are using to find the composition. And then the next one is due pressure equals to 1 over summation of y1 over P1 set. And then next is x1 equals to y1 times pressure over P1 set. So this is all from here and here are related to Rock's law, which is x.
So this is the data and result for the task 1. Predict the vapor composition Y1 and system pressure PT. The next one is task 2. Predict the liquid composition X1 and system pressure PT. And the last one, task 3. Predict the mole fraction of vapor over liquid, vapor composition and liquid composition.
So I'll explain about the next step for the calculation. So next step is the summation of Z I K I over 1 plus B bracket K minus 1. To get a value of Z is actually the mole fraction of the feed, and then to get a value of Ki is actually Yi divided by Xi. And then we need to remember that the value of V plus L must be equal to 1. And then the next calculation step is using this formula, Yi equals to Ziki over 1 plus B bracket K minus 1. This is for us to find the value of Yi. And then the last step is Xi equals to Yi over Ki. And then guys, don't forget that we need to find V value using solve function in calculator.
Now I will explain how to plot the graph. The first graph is x1 versus y1. On y-axis we put the y value and x-axis we put the x value. So the data is from 0 to 1 for both x value and y value. So for the value of x1 and y1, we use the equation that we explained in this video. And then every mole fraction, everything must equals to 1. That's why in our graph, our value n must be in 1. So for this graph, after we plot the value of x1 and y1, we plot also the straight line, which is the equilibrium line of y equals to x. And the next one, the next graph is pressure times with y1 and x1. So for the blue one is P and X, meaning the pressure and the X composition, the composition of liquid, and the red line is pressure times with composition. So there's two different graphs that we did in this project. The first one is x1 versus y1, and the next one is pressure and the composition. Thank you.
My name is Mohamad Asyraaf from Asri. So I will explain about the task B. This is a distillation column. First, we have to solve the mass balance. F is the feed. The feed is equal to the amount of distillate and plus amount of water products. XF is mole fraction of feed. XD is the mole fraction of distillate and SB is the mole fraction of bottom product. D over F is equal to fraction of feed that is vaporized in distillate. F is 0.94. Okay, next we have to find the value of Q to find the Q line.
Q equal to the enthalpy at dew point minus enthalpy of the feed over enthalpy of the at viewpoint minus enthalpy at bubble point. HV minus HL is the latent heat of the feed. Also equal to the HV minus HL, the latent heat of the feed, plus the heat capacity at liquid of the feed times the boiling temperature of the feed minus the temperature of the feed in Kelvin over HV minus HL, the latent heat of the feed. We find the Q value. We can find the linear equation to find the Q line. So y equal to Q over Q minus 1x minus mole fraction of the feed over Q minus 1. Q also equal to the mole fraction of liquid at feed.
My name is Hanis from Zaimi. Now I want to explain about the rectifying line and also the stripping line. Rectifying line, for the rectifying line,
Equation is y equal to r over r plus 1 x plus xd over r plus 1.
XD represent the mole fraction of the distillate, while R represent the reflux ratio. For the stripping line, the equation for stripping
Line is y equal to lm over vm plus 1 xm minus d over vm plus 1 times xd.
basically, if you want to find the theoretical stages, we need to plot the graph. We need to plot the graph YA versus XA. YA is the mole fraction of vapor for composition A, while XA is the mole fraction of liquid for composition A. Then, the first thing we need to do is we need to plot the 45-degree line, which is Y equal to X. Then, we plot the equilibrium curve from the data that we get. Then, we need to plot XD, XF, and XD. XF is always in between XD and XD.
So now here is xf and here is xd and here will be xd. Okay.
The first thing we need to do is we need to do the Q line. Then if the Q line like this, then we got the rectifying line, the intersection between these two, we go until the point of XB, and we get the stripping line. So basically, if we already get all the line, then we can find the theoretical stages by wearing the we find the ratio is between right this divided with this, and we can get the theoretical stages. Okay, if you have a question minimum refract ratio, we need to write the basically minimum refract ratio will give us the maximum stages. Okay, for the maximum refract ratio, basically the rectifying line and the stripping line is lay on the 45-degree line. So it will give us the minimum number of stages. Okay, for the optimum refract ratio, basically the R. And we get from the slope of the minimum refract ratio. So like we take this point and this point to find the then we can get the Rm.
So this is the graph that we've got. First of all, we need to plot x-axis as conversion of methanol and then y-axis as conversion YA conversion of methanol. So the first step we need to plot the 45-degree lines here, and second step we need to plot the equilibrium line here. And then we need to plot 3 points. The first one is bottom conversion, second one is feed conversion, and the third one is distillate conversion. And then from the previous calculation, we already got our Q line, and the second one is our rectifying line. We need to plot the stripping line as well in order for us to calculate the stages. In this case, we couldn't get the stages, the number of stages, because the rectifying line is too near to all the data here. In order for us to get the number of stages, the rectifying lines should be further over for example, at this part, for us to get a number of stages. So in this case, it is too near for us, so we couldn't get the number of stages. So that's the end of the explanation. Hope you guys enjoyed. Hi guys, I'm Ben. So today I will explain to you how are we going to use the macro function in Excel in order to speed up the process to get the wanted value. So our team has actually designed a macro system in Excel. There's 3 parts in here, which is part A, part B, and part C. So I will try to explain to you all every part accordingly. So let's start with it first. So for part A, the goals is actually to get the Y value from nano. So we need to insert the given temperature first. Every group has been given different value for the temperature. So for in this case, for our group is 56 degrees Celsius. And then we also need to insert the saturated pressure for methanol and saturated pressure for water. And then next step, we need to click this button, and then we are required to enter the liquid condition of methanol. So in this case, I will put 0.7, and then it is shown that the vapor composition of methanol is 0.9093, which is shown here. And then the value that we insert 0.7, it will changes in here. For part B, the goal is actually to get the value, the X value for methanol. So the same thing, we need to insert the preset value, the temperature, saturated pressure for methanol, and saturated pressure for water. So in this case, we are required to enter the vapor composition of methanol. For example, I will put 0.2. You can see that the value changes to 0.2, and then the vapor composition of methanol is 0.0550. So it's shown here. Okay, finally, for the part C, we also need to insert the temperature, saturated pressure for methanol, and saturated pressure for water. So part C is designated to get the Z value for the component. So we just need to click this button, and then we need to enter the overall composition of methanol. Here I'll put 0.4, and then you can see that the value changed to 0.4 here. And then we need to enter the system pressure that is between these two pressures, 23.94 kPa and 38.46 kPa. So in this case, I'll put 31, and then we'll get the value. We can see that the K value for methanol is 2.2985, the X value for methanol is 0.2636, and lastly, the Y value for methanol is 0.6059. So that's the end for the explanation for macro Excel. Hope you guys enjoyed. Thank you.